DSP architecture. So first we have already seen introduction part. This one is basic typical communication link, analog input, then encoder and source encoding, channel encoding, then data packetizing, digital modulation. Then in between there is a wireless communication. Then again digital demodulation, channel equalization, journal decoding and reconstruction of source coding and reconstruction filter, and finally we got it analog signal, original signal. It's like our telephone, one end to another end. So the transmitter side they are transmitting and changed to analog to digital, and they are modulating the signal for transferring one place to another place and demodulate and decoding the signal and finally reconstruct the filter, and uh, they got it analog signal out. Then DSP architecture memory. So the interconnection between secondary the instruction and the secondary data, that's a program memory. So the DSP architecture they have the content of PM data address generator, DM data address generator, and data memory data. So data memory, input output controller, and program sequencer, instruction cache, and data register, multiplier, and ALU and shifter. So here the program memory is nothing but instruction and secondary data that is stored in program memory. And PM data addressing generator is program memory data address sequence generator. And DM means data memory data address generator. So the address, there is an address bus between program memory and data address generator, and similarly data memory and data address generator, in between there is a data memory address bus there. Then program sequencer also there. So program sequencer, it has a bidirectional bus is connected between PM and DM. Also they have bidirectional bus and instruction cache. So instruction cache is available, and then data register. So what is register? Register, it's storing the data. You know that it's a flip flop and latch are one bit register. It's a combination or integration of more than a flip flop, that is a register. So the register might be 4 bit, 8 bit, depends upon the size of the register. Here the data register they're having. So that register will be to store the data or instruction or whatever that the temporary data and everything. So that is a data register. So that means it will be store the data. So that connected with the bus of PM data bus connected to the program memory, also DM memory. So everything is bidirectional. Also the instruction cache also connected with the data register, and then the data register also connected with the multiplier, ALU and shifter. So multiplier, ALU, shifters, that is we will see in the futures of DSP architecture. So but multiplier it's one of the DSP application, and ALU and shifter, so these are used in this DSP architecture. And input output controller, it is DMA, direct memory access. So the direct memory access means without interruption of CPU, we can directly access the memory. That means CPU have some other work, but if you're going to ask the CPU, then the CPU will be helped to get the data. It will be take time, and the processing is more. So avoiding that, we can access the memory data, that is DMA controller. So without asking without the help of CPU. Okay. So they are having hold and actually acknowledgement signal like that. So then input output control they are having all the serial port and ADC, DAC, and serial and parallel high speed input output port. Everything are connected with it here. So these are the content and parts are available in DSP architecture. And the next basic architecture features that we will see in next video. Thank you.